In this video lecture, we shall see how to write a stick diagram and a mask layout for a CMOS inverter. Okay. So in the last video lecture, we have already discussed the steps required for drawing a stick diagram in the CMOS design style. Okay. The first step is to draw the VDD and the VSS rail, which I have already done. The second step is to draw the demarcation line. Okay. So the demarcation line basically separates out the NMOS and the PMOS. Then I have to represent two transistors. One is PMOS and other is NMOS. So for PMOS, it is the yellow color which is used. Okay. So I have taken this yellow color. Let me extend it a little bit. Okay. So this is my yellow diffusion. And how do you form a transistor? So transistor is formed when a poly crosses. Okay, I have taken one poly. So this forms your P plus diffusion. Okay, then the size and all you can adjust properly in the paper. In this it's difficult for me. Then we have an NMOS transistor. So the color is the green color. So I've taken the green color. Fine. So this is the diffusion. Okay, let me extend this also. Then again, if a poly crosses, it forms a transistor. So this forms an NMOS transistor. Fine. Now we have to draw the intermediate connections. As you can see, here it is connected to VDD. So I need to extend this diffusion layer to VDD. Okay, so again I will copy this and extend this to VDD. Okay, and you have to show a connection by a dot. So this is over. So this connection. Next, this is connected to VSS. So the same diffusion I will extend. Okay. Fine. This is okay. The poly forms the gate. Okay, and one side is source, the other side is ground. Okay, you can interchange as you can. Okay, so this side I will consider it as source. So I will extend this diffusion. Fine. Then I should also show this connection dot. So this finishes this connection. Correct? Now, what else is left? The gate is shorted of both. So the polysilicon will be same. Okay. So I will extend this and I will connect to this polysilicon. This connection. The gate and gate are shorted. And from that you have taken a V in. Okay. So remember, polysilicon and metal can cross the demarcation line, but the diffusion cannot cross the polysilicon. Okay. So this is your V in. Fine. Should I show a junction dot here? No. Why? Because it is the same layer. So when you are connecting the same layer, The electrical connection is already present. You did not show it by a dot. Now what else? The drains are shorted. Now I have to make a connection between the P plus diffusion and N plus diffusion. How can I do? These are two different layers. So this has to be done by using a metal contact. Okay. So I take the metal contact. Sure. Fine. And I have to show this using a junction board. Similarly here. Fine. Now I have to take an output. Okay. Now if you want to take the output from the metal itself, you can take out. You can have one more metal connection. But if you want to take out from a polysilicon, okay, fine. So this also are the different layers. So you need to show a dot here again. Fine. So this is your V out. This is your V out. Fine. That's it. Okay, you have to show the connections for substrate. So you can place a connection for substrate and a P mask. Okay. One on VSS, the other on ground. So this is your stick diagram in the color coding form. Fine. The same you can have it in the monochrome. Okay. So in the monochrome, how will you show? You can refer the encoding. So the metals, they are represented by black colors. Okay. So I will fill this by black. Fine. And whereas your diffusions are empty rectangular boxes. So you change it by empty rectangular boxes like this. Fine. Poly, it is represented by some black color filling. So as of now we'll fill with this. Same here. That's it. Demarcation line is also a black color. This is the monochrome encoding layout. Okay. So you can draw either the color coding or the monochrome. Okay. So in the next video lecture we shall see the mask layout. Okay. So please draw this by your own. Use the color pencils or the crayons. So you'll understand better when you draw more complex stick diagrams. Okay. Thank you.